So there are probably three different things that you might be asked to do. So I'm going to write those down first. Okay, first thing, you might be asked to find the area of the base. Second thing, we will need to find the area of the cross section. And the third thing is the volume of the figure. So let me give you a generalized overview of those three things, first of all. Okay, so the area of the base, for example, is just the area of this blue region right here. The area of the cross section is where we take a shape and we slice the base. So in this case, it is a circle. In this case right here, it's a square that's sitting on top of the base there, that red square. There was a bad joke in there, right, about Moscow or something, but I won't subject you to that. I'll just move on.
No one likes
All right.
communism.
And the third thing is the volume of the figure. So if I were to take all of the squares from -2 to 2 there and group them together, it would make a sphere. That's like the purple shape here in this second example, okay? If I were to take all of the square, excuse me, all the circles together, okay? So those are the three things. Here we go. It says, let R be the region of the base of the solid defined by the graph y is equal to the square root of 4 minus x squared and y is equal to the negative square root of 4 minus x squared. Suppose the region has vertical cross sections taken perpendicular to the x-axis. Okay, so part A says find the area of R. All right, so I want the area of the base. And this is not new. This is exactly what we did last Thursday. I'm finding the area of a region. And so I'm going to draw my reference rectangle and do the top minus the bottom and then integrate. It's just this figure is showing a three-dimensional version. So I have an X, Y, and Z axis, whereas before we just did two-dimensional. Okay, but all I'm doing here is the top minus the bottom. Okay, so I'm going to integrate. My bounds in this case are from -2 to +2. I take my top equation, which is square root of 4 minus x squared, minus the bottom equation, which is negative square root of 4 minus x squared. And all of that is with respect to x. And so I'm going to simplify this a little bit. Come down here. I have the integral from -2 to 2. I've got a negative square root of 4 minus x squared. So that gives me a positive. So I've got a square root of 4 minus x squared plus a square root of 4 minus x squared, which is 2 square root of 4 minus x squared with respect to x. So take your calculator and use math 9 to find the area of the base there.
That top one will still give you the same thing.
Yes, yes, that's fine. Okay, and you should get 12.566, which is correct.
That's the answer.
That is the answer
Okay,
for that part.
so what is it though? I'm confused.
Okay, that is the area of the blue region.
What's the red thing?
We'll get to that.
Okay.
Okay. But that's the area of the blue region. What's another way I could write 12.566?
12.5 to the 6 with the line on top of it.
Okay, it is 4 pi.
Yeah.
And let me show you, well, it's actually pretty easy. Let me show you why. What is the shape of the blue region? It's a circle. How do you find the area of a circle?
Divide by 2.
It's pi r squared. Shh. And the radius is 2. Hold on. So why did I make you use calculus? Well, number one, to show you that it works, right? Number two, it's not always going to be a circle. Rarely will it be, okay? And so we need to use our knowledge of calculus to do top minus the bottom and integrate, okay? So that's the first thing. That's the area of the base. Second thing, if the cross sections are circular disc with diameters in the XY plane, okay, that means that I'm slicing the base with circles. And the diameter of the circle is lying in the XY plane on the blue region there, okay? Express the area of the cross section and the volume of the solid. So I have some steps for you to do. Okay, so number one, find the formula for the area of the cross section.
Attendant plate.
Find the formula for the area of the cross section. Number two, find the limits of integration. Number three, integrate the area for volume. Find the formula for the area of the cross section. Then we're going to find the bounds of the integral. Then we're going to integrate from bound to bound. And that's going to give us the volume of the figure that is generated there, which in this case, since these are circles, it would be the volume of the sphere. Okay, so step number one, this says that my cross sections are circles. And so the area of the circle is pi r squared. Okay, but here's the problem. Okay. So this is a cross section that has a certain area. This is also a cross section that also has a certain area. Which one is larger? It's the second one, right? Because it's a bigger circle. Well, here's the problem. There's an infinite number of circles between -2 and 2, and therefore there's an infinite number of areas. So what I need is I need a general formula that will give me the area of any of those circles. And so here's how I do that. All right. I need pi. And then I need an expression for the radius. Okay, so look up here for just a second. Okay, and let's look at the radius of this circle. The radius goes from right here in the center out to the edge, correct? That's my R. This value is a Y value. Look at it, okay? I'm going from there up to there. That is a Y value. let me draw it two-dimensionally so that you can see it. Okay, so this is my base. Okay. Got X, I've got Y. Okay. It's kind of hard to draw there, all right, but let's say that that's my circle. Well, from there to there is the diameter, so halfway from there to there is a Y value. So everybody see that? Okay, that's not the best picture, but let's look at it again, all right? I'm going from here to here, and probably should use this.
Are we measuring the half sphere or the little red thing?
Hold on, let me draw it on here. That's probably better, you can see it, okay? That's a circle of a cross section, right? And so the radius of this cross section goes from right there to right there, correct? Well, in this plane, that distance is a Y value. In other words, it's lying in the plane along the same plane as the Y plane. Does that make sense? I have an expression for Y. Y is equal to the square root of 4 minus x squared. Okay, so if I put the square root of 4 minus x squared in here, that gives me R. Does that make sense? You follow me? And then this needs to be squared because it's pi r squared. So here's what I have. I have pi. The whole expression is squared because it's pi r squared. And this is 4 minus x squared, which is an expression for the radius from right here to right here. And that's the expression for my radius because from here to here is a Y value. And they tell me that Y is equal to the square root of 4 minus x squared. Okay, got it? Okay, so here's how you set it up. All right, you have volume equals the integral. I'm still going from -2 to 2 because my base has not changed. And then I'm going to plug in the formula for the area of the cross section. In other words, I'm going to take all this and plug it in. So I have volume equals integral from 2 to -2. And then I'm going to take pi times the square root of 4 minus x squared and plug it in. But let me clean it up a little bit. Okay, so the pi I can move out front because it's a constant. And then I have the square root of 4 minus x squared squared. So that's just going to give me 4 minus x squared dx. And now I'm going to use my calculator to calculate that volume. Okay, so do that. And so you should get 32 over 3 pi, or 10 2/3 pi. Or if you leave it as a decimal, what is it, like 33.551? Either one of those. And I don't see units here, but that would be cubic units, right? Because it's a volume. All right, let me pause there for just a second to make sure that everybody is with me here. Okay, so any questions about that example or how I generated any of the equations?
So we found the volume of the
It would be the
sphere?
volume of this purple shape, there, the
Okay.
sphere. Okay? Everybody okay? All right, here we go, part B. If the cross sections are squares with bases in the XY plane, express the area of the cross section and volume of the solid. Okay, so my blue base region has not changed. The cross section has changed. It is no longer a circle, but it is now a square. And the square is sitting on top of the blue base. Okay, and so they want me to find the area of that cross section, the square, just like we did in the previous one. And then if I were to generate a three-dimensional, if I were to find all of the squares from -2 to 2, it's going to make a three-dimensional figure that's similar to the purple shape there. Okay, so that's what we're doing. All right, so I need to find the area, a general formula for the area of a square, which is what? Area equals,
Length times width.
that's true, but it's a square, so they're the same, right? So I'm just gonna call this side square.
That doesn't look like a square to me though, you know what I mean? It looks like a rectangle.
It's,
I'm just saying.
it's your view. From over there, it kind of skews it, right?
Yeah.
But you can do base squared or side squared, something like that. Okay, so now let's look at this. Here's what I need. I need all of that. That's my side. So you can generate this one of two ways. Okay, here's the first way. I'm gonna do like I did on the first one, where I found the radius, and the radius was a y value, right? Well, here, the y value, it's not going to give me the entire side, it would give me half of it, right? So I could double it. So I got 2 times the square root of 4 minus x squared. This right here is my side. And then I need to square it. Okay, so you can do it like that. So look up here again. Look at my figure here. If I go from the x-axis all the way out to the edge, that's half the side. And that is my y value. Therefore, my y value is 4 minus x squared. And if I double that, I will get all of it. Or you could think about it like this. I'm going to do 4 minus x squared minus a minus 4 minus x squared, which gives me square root of 4 minus x squared plus square root of 4 minus x squared, or 2 times the square root of 4 minus x squared. And then don't forget to square it, because this expression right here is just the side. And to find the area, I need the side square. Okay, so this is the area of my cross section. Now I'm going to find the volume. The bounds have not changed, so it's -2 to 2. And I'm going to clean this up a little bit. I've got 2 squared, which gives me 4, and I square the radical. And it's going to go away. So I've got 4 times 4 minus x squared. And then that's with respect to x. So now take your calculator and math 9 it. And we can crank out the volume. And let's see, I got 128 over 3, or 42.666 repeating, or 42 and 2/3.
Is it looking for the volume of the whole thing?
It's finding the volume of this purple shape here, which is generated by finding all of the squares from -2 to +2.
I still don't get how like that's half the thing.
Okay. Let me go back up here. And draw a square on this. Okay, so here's the square. The square is sitting with the base and the XY plane. Correct? Okay, so this right here is the Y value from the x-axis to the edge. That's a Y value, right? And I know that Y is equal to the square root of 4 minus x squared. Right? Well, that's only half of it because on the other side, it goes from the x-axis all the way over here. So to get the entire side from there to there, which is S, I need to double the Y value.
Oh, so we assume that the equation that they gave us is just half.
It's symmetrical, and so you can't assume that, and it's symmetrical because it's a circle. And it's equidistant from the center.
So like this y equals is just from 0 to 2. Not -2 to +2. It's just
Well, it's 0 to 2 on the y-axis from there to there. Yes.
okay.
You understand why we double it?
Yeah.
Okay.
I don't-
Any other questions on the first two examples?
Is S the radius? No. it's
S is the
diameter.
side. S is the side, which, right, if we were doing it on this with the circle, it would have been the diameter.
So what is it on B?
On B, S is from one edge of the base all the way to the other edge of the base.
What's the diameter?
If you're talking about a circle, but we're not talking about a circle.
Yeah.
I'm sorry, you're talking about the diameter of the
It's
base?
just big.
Oh,
Yeah.
I'm sorry, yes,
Yeah, so-
exactly. It's the diameter of the base. All right. Let's dive in a little deeper. All right.
We're still going?
Didn't think we'd just get halfway through in midstream and like
Well, that
jump
was-
off our horse in midstream, right? The current would just carry us away.
That was a lot for me. That was like.
Woo! Oh,
And you get
man.
This is hefty too.
man, what is this? It's
Yeah,
like,
how come this is like
it's like calculus is not a blow-off class, man. I mean, come on, Newhouse, what is this? We have to learn. Oh. All right, here we go. Example 2. Let R be the region of the base of a solid that lies between planes perpendicular to the x-axis at x is equal to -1.414 to x is equal to +1.414. The cross sections perpendicular to the x-axis between these planes are circular discs whose diameters run from the curve y is equal to 1/2 x squared to y is equal to 2 minus 1/2 x squared. Express the area of R, the area of the cross section, and the volume of the solid. So the first thing I'm going to do is label the diagram that they gave me, okay? So I have this top equation. It's y is equal to 2 minus 1/2 x squared. I know that it's that one because it is a parabola that is inverted. And so my x squared must be negative since it's inverted. Right, which means the bottom equation is y is equal to 1/2 x squared. And also, they are kind enough to give me the intersection points, which I could find using my calculator, right? But this intersection point is -1.414 or
square root of 2.
negative square root of 2, right? And this one is positive square root of 2.
I do that.
Okay,
So if you don't know,
you can just leave it.
well.
That's
yeah,
fine.
Well, so what have your answer?
Oh, why do we do it?
Okay, so all they said was express the area. So that means I do not have to evaluate. I just need to set it up. Okay, so I need the area of the base. All right. What shape are my cross sections? How do you know? Because it says right here, they are circular discs. Okay, therefore, area is going to be pi r squared. I'm sorry, I was talking about the cross, I skipped one. I need to go back. Okay, because that's the area of the cross section. It says, first of all, express the area of R, which is the base. Okay, so my bad, I skipped one. I need top minus the bottom there for the area of the base. So the area of the base is going to be the integral from negative square root of 2 to positive square root of 2. And then I'm going to have my top equation, which is 2 minus 1/2 x squared minus the bottom equation, which is 1/2 x squared. And that's with respect to x.
Let's go. Do this.
Okay. And so I don't have to evaluate it, but I'm just going to clean it up just a little bit. This is the integral from negative square root of 2 to positive square root of 2. I've got a negative 1/2 x squared and another negative 1/2 x squared, which gives me a negative 1 x squared when I collect the terms. So I've got 2 minus 1 x squared dx. And so that will give me the area of the base.
Wait, okay, I'm gonna be a little stupid. Why did you put those bounds? Do we always do the intersection?
Yes, yes. That's what we learned last week.
Is that what we were doing last week?
Yes. Okay, so that's the first part. The area of the cross section. The cross sections are circles. And it says their diameters run from curve to curve. Okay, so in other words, I've got a circle and the diameter of the circle goes from the top curve to the bottom. In other words, this equation right here is the diameter. Yes? Yes. Okay. So look at my little drawing here and imagine a cross-section circle. Okay. So this says that the circular discs, their diameters run from curve to curve. So if I have a circle here, from the top curve to the bottom curve gives me the diameter of the circle. And this expression, which I just found, 2 minus 1 x squared, is therefore the diameter. Okay, so now I need to write a formula for the area of the cross section. All right, so I'm going to have the integral from -2, negative square root of 2 to positive square root of 2. And I need, sorry, let me back up. Let me just do the area. I was doing the volume. Okay, I need pi. And since this is the diameter, I get the radius by dividing by 2. Because the radius is 1/2 the diameter, correct? So I have pi 1/2 2 minus 1 x squared and squared. For this right here is my radius. Okay, so look, let me go back through that. All right. Look up here. I need to find the area of the cross section. Cross section is a circle. Therefore, it's pi r squared. So I've got a pi, I've got a squared, and then I've got an expression for the radius. The expression for the radius, I found the diameter because look, the diameter goes from the top equation to the bottom equation, which comes from what I found in the first part. I need the radius, so I'm going to divide that by 2 or multiply by 1/2. So my expression for the area of the cross section is pi times 1/2, 2 minus 1x squared, and then all of that is squared. And so the last thing that they wanted me to do is to find the volume. And so now I'm going to integrate that expression from -2 to +2. Okay? I can move the pi out. Square root of 2, square root, negative square root of 2, positive square root of 2. And then I've got 1/2, 2 minus 1x squared, squared. Somebody asked if you could move the 1/2 out last period. And the answer is yes, but it's not 1/2. It's really 1/4 because it's squared. Okay, so I could move out a 1/4 pi out front if you wanted to, but you don't have to. And you don't even have to move the pi out. You can leave that in if you want, that's fine. Okay, but they didn't ask me to evaluate this, so I'm just going to leave the expression like that. Okay, so take a look at that.
What did you get? How'd you get from the top to
From right here to right here?
how'd you
I
get-
collected these two terms. So I have -1/2 x squared minus 1/2 x squared, that gives me -1 x squared.
Okay, why did that give you the diameter?
Because, again, if I go top to bottom, that gives me everything in between the two equations.
Mhm.
Therefore, if I were to draw a circle around that, that would give me the diameter of the circle.
Oh,
Okay,
yeah.
got it? Other questions?
On the AP test, if you didn't simplify, they'd still give you the terms.
Yes.
Isn't the area of the base the same as the area of the cross section?
It's not in this case because of the pi there.
Wait, did we just solve for volume?
That's the volume, the last one. But my area of the cross section is going to be a circle, right? And this is not a circle. So the area of that, of the base, is going to be the integral from negative square root of 2 to positive square root of 2 of 2 minus x squared. That gives me the area of the base. But the area of the cross section is pi r squared, which is a circle. And so that's going to give me pi times 1/2 the diameter squared. You follow me?
That formula gives area though.
Yeah.
Like
That's
regular
right.
area.
One at a time. Jacob, ask your question.
Look at that, the integration on the area of the base. I thought that formula gives you the area in between
That gives me the area
of the whole thing,
of
right?
the whole base there. Yes.
Yeah, then how does it give you diameter? Or no, it doesn't, the middle of things.
No, what I'm saying, Jacob. Okay, so look,
I don't know. There's one-
Are you confused or you understand?
No, I knew what he said.
Oh,
I don't
okay.
get what-
I'm good
I
then.
don't
I'll
get
just,
what you're trying to
I'll just learn from this, just like right there. too.
Let me show you.
Oh, you cut and paper, oh, the arts and crafts. Okay. Alright.
All right, I want to make sure you understand. Let's say that this right here is a crude estimate of the area of the base. Okay, so to find the area of this, I've got my top equation, which is the parabola, the bottom equation, which is the parabola. Okay, I do top minus the bottom, and then I integrate from the intersection points, this one to this one. Right, that's what I got right there. And I simplified it to this. So that would give me the area of this.
Mhm.
Okay, so now I have a cross section, and the cross sections are circles. And it says that the diameter runs from the top to the bottom. That means, okay, I can't show this without slicing this, right? But that means that I have a diameter going from the top equation to the bottom equation in this, so that it looks like that. Imagine if this were halfway between this styrofoam soccer ball. Does that make sense? So to find the area of this cross section, okay, it's sitting like this, but halfway between. It's pi r squared. And then this right here from top to bottom is the diameter of the cross section circle. Does that make sense? Okay, so I have pi, and then I have 1/2 2 minus x squared, because 2 minus x squared is the diameter.
Oh, okay. I get it. I get it now.
Then I square it because it's pi r squared, the radius squared. Does that make sense?
I made it a lot better.
Okay, then to get the volume, I've got to integrate the area of the cross section, and the area of the cross section is pi 1/2 2 minus x squared squared. So, sorry. This right here is the volume. Okay. This is the area of the base. This right here
I'm gonna circle it too.
is the area of the cross section. Got it?
One second.
That was a little, that was a little rough, but it's okay. That helped, okay.
So the area of the cross section isn't identical.
It's not,
That makes sense.
okay? And so maybe that's my fault probably because I didn't do it step by step. But this is the area of the base, and that is an integral. The area of the cross section is pi times 1/2 2 minus x squared squared. And then if I put that into the last step here and integrate that from negative square root of 2 to positive square root of 2, that gives me the volume. Okay, here we go. Let's do another one. This one's fun. Okay, the solid lies between planes perpendicular to the x-axis at x is equal to 1 to x is equal to 4. So they are giving me the balance. The cross sections perpendicular to the x-axis between these planes are squares whose diagonals run from the curve y is equal to 3 over the square root of x to y is equal to -3 over the square root of x. Find the volume of the solid. So the first thing you need to do, since you don't have a diagram, is graph the equations. So take both equations, put them into your calculator, and graph them.
tempted to do.
Okay, so you should get something that looks similar to this. Except here's the difference, okay? Let me go back up to the cross section is a square, right? But on this one, it says the squares are bases in the XY plane. That means that if I have a base, and imagine this is a square, the square is sitting on top of the base, correct? But here it says that the diagonals run from curve to curve. So if I go from here to here, that means, look up here, okay? It's hard to draw, I know, okay? So look, instead of my square sitting on top of the base, it's turned so that the diagonal goes from curve to curve. Okay? So in other words, look, it's a diamond. Okay? And it's got a triangle on the top and a triangle on the bottom. Does that make sense? Okay, and if it looks like this, okay, this is sitting on top, this, it looks like this, where you have a triangle on the top and a triangle on the bottom. Okay? So they asked me to find the volume of that. So first step is to find the area. What's the area of the square? It's just side square. Okay? But here's the difference. And the last one, it looks like this. So this is a side, and then I have the diagonal. And so the diagonal is going to be
Make them in
the
triangles.
side times the square root of 2. Okay, look, there's 2 ways. Okay, it's a 45, 45, 90 triangle. So I've got side, square root of 2, or use the Pythagorean theorem, and you get side times the square root of 2. So here's what I got. I have the diagonal equals side times the square root of 2. Everybody okay with that?
Yeah.
Where are you getting square root of 2 from?
It's s squared plus s squared equals the diagonal squared. So then I have 2s squared equals the diagonal squared. And then I take the square root of that. The square root of s squared is s. And I'm left with the square root of 2. It's the Pythagorean theorem. Okay? Okay, so look, since my area formula is in terms of s, I'm going to solve for s, and I'm going to write this as s is equal to the diagonal over the square root of 2. Everybody okay with that? All I did was solve for s. Well, hold on. So now I'm going to take this and substitute it into my equation. So I've got the diagonal over the square root of 2 squared.
Why is it squared again? Oh,
It's the area of a square.
oh,
Okay, so let me summarize what I just did. Pay attention. Okay. Area of a square is side squared. They give me things in terms of the diagonal, so I wrote the diagonal as the side times the square root of 2, because it's a 45, 45, 90 triangle. I solve for s. So s is equal to the diagonal over the square root of 2. I took the diagonal over the square root of 2 and substituted it into my equation for s because they're equal. So I have the diagonal over the square root of 2 squared. That's where I'm at. Now I need an expression for the diagonal. Okay, well, that goes from the top curve to the bottom curve. correct? So I've got 3 over the square root of x minus 3 over the square root of x. So that gives me 3 over the square root of x plus 3 over the square root of x. So here's what I got. Area equals 6 over the square root of x divided by the square root of 2. And all of that is squared. So all I did was write an expression for the diagonal. And to write an expression for the diagonal, I do the top curve minus the bottom curve, which gives me 6 over the square root of x. Yes? So now I'm going to square everything. So I've got area equals 36 over x over 2. I squared the 6, I squared the square root of x, I squared the square root of 2. So now I'm going to flip and multiply. It's divided by 2, so I flipped it and multiplied. That gives me 36 over 2x or 18 over x. And so that is the area of my cross section.
Okay, I'm gonna ask you a quick question.
Mhm.
Super fast. Why does, I still don't get why that would give you the diagonal. The top minus bottom.
Okay. Well, think about it like this. You can think of it like this. What is half the diagonal? It goes from there to there, right? And that's a y value.
Yeah.
And what's the y value? 3 over the square root of x.
It's the equation, right?
Mm-hmm. It gives me that right there. Y is 3 over the square root of x. So I could double that, right? And I would get 6 over the square root of x.
Okay.
Okay. Or you could do the top minus the bottom, and it will give me all of that.
But how do we know it's that point? I was saying,
It's at any point. It's at any point. This is just a generalized formula that gives you the diagonal for any point between 1 and 4.
okay,
Wait, we still need to find the volume, right?
Yes.
So how come that turns into 36 over 2x? If you're just multiplying the fraction, multiply straight across, you have to multiply the top fraction as well as the bottom
Multiply the top, multiply the bottom. What's 1/2 times 1/2? 1/4. Okay. Got it? Okay. So I'm going to integrate from 1 to 4. Why is it 1 to 4? That's what they told me. 18 over x dx.
still going.
Plug that into your calculator.
It's not 18 over x squared. Since the
Because look, this right here, this is the square root of x, and I squared it.
okay.
And you should get, I got 24.953 for that. All right, stay with me. Almost done. One
Yeah,
more.
we gotta hurry this one up.
Quickly. We got a little FRQ,
Let's hurry.
okay?
Wait, are not like-
Do it. I just found it. It's right there.
Yeah, we gotta go.
All right, here we go. Let R be the region in the first and second quadrants bounded above by the graph of y is equal to 20 over 1 plus x squared and below by the horizontal line y is equal to 2. First thing I'm gonna do is put this into my calculator. Okay, and part A and graph it and look at it. Part A says find the area of R. Okay, so let's graph it. And you need to be careful on this one. Okay, here's the line, y is equal to 2. Because those dirty rotten scoundrels at the college board gave you something that's not gonna fit in your 10 by 10 window screen, that 20. So change your window settings. All right. But it's going to give you something that looks kind of like that.
Yeah.
Yes. And I'm going to find the intersection points, which should be at -3 and +3.
I'll take the word off.
Okay, so I've got my top equation. I've got my bottom equation. They want me to find the area that's enclosed there. So I'm just going to do top minus the bottom and then integrate on part A. Right, so part A, I have the integral from -3 to 3. My top equation is 20 over 1 plus x squared minus the bottom equation, which is just 2.
Yes, two.
And I put that into my calculator. So do that for me,
How did you solve for the trees? Like, how did you get those? Did you just,
intersect on the calculator. Use the second trace intersect button.
I got 37, is that right?
37.962.
Let's go.
All right, part B. It's a preview of coming attractions. We're going to take this and rotate it around the x-axis, but we're not doing that today. We're doing that later. So I'm going to skip that and do part C.
Let's go.
All right. So here we go. Part C. Part C says the region of R is the base of a solid. For this solid, the cross sections perpendicular to the x-axis are semicircles. Find the volume. Okay. So I've got area equals pi r squared divided by 2 because it's a semicircle. Yes. So what you have is you have this semicircle sitting on top of the region.
Let's go.
So again, look up here. If it goes from the top to the bottom, that's the diameter. Correct?
Yes.
So this expression that I had in this first part was the diameter. And so if I want the radius, I need to divide it by 2.
Okay.
So here's what I got. Okay. I didn't draw my line very well. Let me redo that. Okay, so look, this right here gives me the diameter. Right? That's what we found in the previous one. This 1/2 I have there because it is the radius. And then this pi over 2 is because it is a semicircle. Okay. So I'm going to move out the pi over 2 and move out the 1/2, but the 1/2 is squared. So I got 1/4. So you have a pi over 8 out front. I'm going to integrate from -3 to 3. And then I have my expression 20 over 1 plus x squared minus 2 with respect to x. And please don't forget that square there because it's squared. Plug that in.
Yeah, can you do it for me, Mr. Nuss, this time?
And you should get 174.268 units cubed.
Coach,
I finished just in time.
coach, so for A, that first thing that you solve is not always gonna be the diameter that
Thanks.
we use for that second part.